Good morning one and all. Now we are moving towards important topic of the chapter, which is known as Gauss Law. Remember that Gauss Law is one of the fundamental law of nature. As you know that we have four fundamental forces: gravitational force, electromagnetic force, strong nuclear force, and another one is weak nuclear force. But this is law, and it is one of the fundamental law of nature. Okay, so this is very important topic. Remember, in exam, final exam, you will get one question from this topic. So this is initially how to solve Gauss law that we are going to see. So consider this is one sphere having radius small r. Okay, and at the center of the sphere positive charge q is located. Okay, so that I am writing over here. Consider a point charge q located at the center of the sphere of radius small r as shown in figure. Now here we are going to find Gauss law, but how? Let's see. This is positive charge, means in this direction, means in radially outward direction we have electric field. Okay, it is produced in all direction, radially outward direction, as it is a positive charge. Now at the surface, since it is a sphere, at surface let us consider one small segment, delta s. It is delta s, remember, s, delta s means surface area. This type of surface area we will get at the sphere, surface area of the sphere, and all this surface area, it means small elements exactly at a distance from r. That is the concept that we are going to use here. Means what? Divide the sphere into small area element, delta s. So whatever flux associated with this surface area element, that we can write by using equation of flux, which is delta phi. Since we are using small area element, so flux also small, so we are using delta phi equal to E dot delta S. Since it's a dot product, so we are putting dot over here, where E stands for electric field, so which is we have kq upon r square, k equal to 1 upon 4 pi epsilon naught. Okay, 1 upon 4 pi epsilon naught into q upon r square into r cap, where r cap will be the unit vector along the direction from the center to the area element. So here we are putting value of E, so we will get this equation. Remember, over here this is dot product and this is simple multiplication. Fine. Now let us see here, area element delta s and r cap vector have in a same direction. Okay, so first of all we have to solve this dot product. Okay, so delta s equal to, we have, it means area element equal to its magnitude and its direction. Okay, so that while we are putting, so r cap dot r cap equal to, we have 1 as per property of dot product. So over here direct answer we have r dot r equal to 1, this one, r dot r equal to 1, this one, and then whatever remained quantity q upon 4 pi epsilon naught into r square into delta s. Now here see, this is simple multiplication form, it's not a dot product, so over here no need to put dot, remember. So sorry, this is electric flux produced at a small surface area delta s. Okay, now we would like to find total flux over here, whatever flux associated over the surface area. So net electric flux, how to find? Let's see. Total flux through surface is obtained by adding up flux through all different elements. Means how to do it? 5 equal to delta phi 1 plus delta phi 2 plus delta phi 3 and up to nth number of small element. Okay, so by adding summation all surface area, and then we have equation q upon 4 pi epsilon naught into r square into delta s. Okay, so this we are putting over here since we are going to add all surface area of the sphere. Okay, so total surface area of the sphere, as you know that it is a 4 pi r square, so that we are putting value over here. So next step of flux phi equal to, we have q upon 4 pi epsilon naught r square as it is, and the value of delta s equal to, we have 4 pi r square. So 4 pi into r square will be cancelled out. So final answer for total flux associated with the closed surface area is q upon epsilon naught, where q equal to total charge enclosed by surface area, or we can say with surface area. Means at present in our case we have only one single charge particle, so that hence we are using only q upon epsilon over here. Okay, but suppose more than one charge particles are associated with surface area, in that case here you have to add all charge particles like this, and then you have to write your answer phi equal to summation of q upon epsilon naught. Now let us see example. Suppose this is the system having 5 charge particles q1, q2, q3, q4 and q5. Out of them q3, q4 and q5 prepare one loop. It is known as Gaussian loop, remember. And while this loop is prepared, in that case q1 and q2 are out of the loop, hence we are not going to consider q1 and q2. It means what, they are not responsible for preparation of this Gaussian loop. So over here total flux enclosed over here in Gaussian loop will be q3, q4, q5 addition divided by epsilon naught, means what, summation of q upon epsilon naught. Okay, so by this way you have to find out total flux associated with a Gaussian loop. Fine. So this is simple theory of Gauss's equation. Okay, and Gauss law is one of the fundamental law of nature. So be remember, this is very important law. And again I am telling you that you will get one question in final exam from this topic. So this topic is very important. So be careful, pay attention for this topic. That's all for today. Now let's take a recap, simple recap to write the theory.